let's go ahead and continue our discussion by now comparing these Jovian planets. So this is an overall image of how far away each of the planets is from the sun. So we have Mars here just to kind of gain perspective a little bit. We have Mars here, then we have Jupiter, Saturn, Uranus, and Neptune. Okay, and so down here we have the scale. This is in light hours, but we can go ahead and just look at the astronomical units. Remember that one astronomical unit is the distance from Earth to the sun. Okay, so this shows that Jupiter is 5.2 times farther from the sun than Earth. Saturn, 5.5 times as far. Uranus, 19.2 times further, and Neptune, 30.1 times further from the sun. Okay, and we have that here. This is data from NASA. Um, NASA has a great website that has all of the information that I actually got my information from, because that is going to be the best source. And so in this table, it has the distance from the sun, the mass of the planet times that of Earth. So this would be for Jupiter, for example, we have 317 approximately Earths that would make up one Jupiter. Then we have the radius, again, times Earth. So the radius of Earth times 11 would make up Jupiter. So that's what we saw before when we were looking at the putting Earth on Jupiter, how many times we can do that. Then we have the rotation period in hours. So that is about 10 hours rotation period. So that means it takes 10 hours to complete one full rotation on its axis. Then we have the orbital period in Earth years. So almost 12 years to complete one full orbit around the sun. We have the orbital velocity, so how fast is this object going through space in its orbit. So for Jupiter, that's 13.1 approximately kilometers per second. Now, to put that kind of in perspective, there are about 1.6 kilometers per mile. So this would be, I want to say, let's see, 13, maybe like 15 to 16, don't quote me on this, but about that miles per second. Okay, so no, wait, did I go the wrong way? So I'm trying to do a conversion in my head and it's not working very well. So let's see. Let me just do this real quickly. So now it is going to bother. So 13 divided by 1.6. Yeah, I did that the wrong way. Whoops. Okay, so that would be about 8 miles per second. So for every second in time, Jupiter travels 8 miles. Okay, so that kind of helps us put into into perspective, because in America we use miles, feet, inches, and a lot of other countries and in the scientific community, we typically use meters as a base in length. So just to kind of give you guys an idea, it would be about 8 miles per second. Okay, that's how fast Jupiter is traveling. Now, it also states the natural satellites that have been known and confirmed. So for Jupiter, it'd be 87 or so. Then it talks about what is composed of with its rings. So what are the rings composed of? So for Jupiter, it's mainly dust. It's very thin. Remember, we can't really see it super well. Then we have Saturn. It's an extensive system. It has many rings to it. Then we have Uranus, thin and dark, and Neptune, broken ring arcs. So we have, again, not very prominent. Then we have some different properties. This is from our textbook. Um, and this again will give you the distances, the period, diameter of the planets, and the masses, where Earth would be 1. So that's the same thing like I talked about in the last slide, where we compare this to Earth. So Jupiter would have 318 times Earth masses. That would be its entire mass. Then we have its density and rotation in hours. Just note that all of these have a strong magnetic field that are generated by electric currents in its rapidly spinning interior. Okay, so it's due to that interior spinning that we get a magnetic field. All right, and here is one of the last slides showing you guys the composition and structure of each of the planets. So first we have Jupiter, where we have some sort of rocky core. Of course, these are what we think so far in our research. Okay, so this is continuously we are building upon our research and knowledge. Okay, but as of now, this is what we have found. So we have a rocky interior, we have a layer of ice outside of that, and then a huge percentage of metallic hydrogen here for Jupiter. And then on the very outer layer, we can say, is molecular hydrogen. Okay. And notice that Saturn is very similar, but the percentages are a little off. Let's see. We have metallic hydrogen is much less than in Jupiter. But molecular hydrogen, there's definitely a larger percentage of that on in Saturn. Okay, and note that these outer um, layers may be a little bit part of the um, atmospheres as well. Okay, so just make note of that. Then we have Uranus and Neptune, and these are very similar. Again, rock interior, ice, and then molecular hydrogen. So these don't have any metallic hydrogen. Okay. All right. So here is the atmospheric structure. Now, don't worry too much about these, but I just kind of wanted to point out the altitudes at which these occur. Okay. So for Jupiter, we have H2O in the surface. I'm sorry, at some altitude. Then we have a couple of other gases, and we can see how high our gases are. Okay, so they're pretty high up in the altitude. So remember that altitude is going to be from the surface level of the planet. And so as you increase in altitude, we'll get more and more of just the atmosphere. And so comparing that to Saturn, underneath the surface, so this would be the surface level 0. Underneath the surface, we have very different gases here. Okay, so we have H2O, or I guess I should say different amounts of gases. So this is where the H2O would start, this is where this next gas would start, and so forth. Then we have Uranus and Neptune that again look very similar, and we have hydrocarbon ices in the upper atmospheres. Okay, so this, again, not looking at the temperature or anything like that. I just wanted to show you the basic differences between them. Some of these have a higher altitude where they start, some have a lower altitude. And the composition is pretty interesting because um, these two, Jupiter and Saturn, you can see they have very similar molecules, or I'm looking for a word and I'm missing it. Very similar atmospheres. It just has to do with the altitude. And then Uranus and Neptune, same thing. They have very similar compositions in their atmospheric structures. Okay, so that's kind of what I wanted to compare here, just to compare that these two are very similar, and so are these two. Whoops. So let me just say similar. Okay. All right, so next time we have a lecture, we will talk about the rings, a little bit more in the rings, the moons, and Pluto. Can't leave him out. And we'll go a little more in depth. So I briefly mentioned that they have moons, so that's nice, but I'm going to talk a little bit more. And with that, I'll also talk about the debris of the solar system. So looking at asteroids, meteors, and comets. So I'll talk about all of those. What are the differences? What are they like? And I quickly wanted to show you guys. Oh, I don't think I can click on it. Oh, shoot. Let's see. Nope. I wanted to show you guys. New window. Come on. Wow, it does not like me right now. Okay. Want to show you guys the NASA site. Whoops. Where I got this information because I think it would be very helpful. And I did this as well in the last lecture. Okay. So, I want to look at the solar system, our solar system. So we can look at our solar system as a whole. Okay. And there's this really cool thing in each of these that are 10 things we want to know or need to know about the solar system. And so it breaks it down. And it also has each of our planets. So we can go here. It'll tell us how many planets there are, what they, which ones are which. So we have the inner rocky planets, and then we have the outer planets, the gas giants that we just talked about. And you can go through each of these, click on each of these, and it'll tell you more information. So if I want to know about Jupiter, it will give me quickly some information here about Jupiter, and if it'll load, it'll give me an image, which is really nice. Come on. There we go. It's loading. But it'll give you a really cool representation of the planet. And of course, these are artist depictions, but it's very nice to see visually, and you can even kind of move it around, see what side is facing the sun. That would be the lit side, right? And we can scroll down and get some other information. So up here, it does have a little bit of information: length of a year, distance from the sun, number of moons, all of that, where it gets its name or what its name means. And then it'll give you some information about that planet. So there's some 10 need to know things. Largest planet, fifth planet from our star, so forth. It tells you a bit about if it's been in any kind of pop culture references, which is kind of interesting, and a kid-friendly Jupiter, which I think is kind of fun. If you have kids or one of your relatives and you want to talk about what you're learning about, I think this is really cool. So I think if you guys were to look at this, explore it, it's a really cool tool to look at. Whoops. On our computers. Let's see, what is this? Ah, that lights it all up. If I say Jovian system. Okay, so I just clicked Jovian system and it shows me the orbits of the 4 largest moons that I talked about. And Juno, what is that guy? Ah, it's a spacecraft. That's what I thought. Okay. So this is very interesting. It's very interactive, and you can do this with all of the planets. Um, say I do it with Earth. I feel like Earth would be um, maybe a lot with its um, okay, it's thinking. Inner solar system. Let's look at Earth. Come on. There we go. So it shows you some of the orbiting satellites that we've got orbiting us. The ISS, of course. Um, and we have many more satellites than it's showing, but these are probably the ones for research, I would assume, since that's what NASA is interested in. But of course, we have other satellites from companies that are Terran system. Okay. All right. So again, we've got some orbits that are way out there. And we can click on them, see what they are. So this is an X-ray observatory, so it will view light in the X-ray. Yeah, so this is a really cool tool. I definitely recommend it if you want to look at these different planets and their moons and so forth. So yeah, anyway, so I just wanted to show you guys that real quick, and that's all I have for you guys today. And if you have any questions, please let me know. Of course, I am here for you guys. Thanks.